Welcome to the walkthrough for the frequently made mistakes for assignment 4, parts A and B. First and foremost, make sure to always document your code. That should go without saying, but people keep not doing that. Next, let's take a look at some of the various problems I've seen. Here's the new thread factory method. In this implementation, make sure that you do a more concise way of giving the thread its name. Take a look at the Java thread class documentation and look at all of its constructors to see how to do that. Also, please use increment and get instead of add and get one, since that's also a simpler thing to do. Let's take a look at a number of problems I saw with the execute on executor method that was supposed to be implemented in the async beings.java file. First of all, why pass a magic number like 10? That shouldn't be hard-coded. That should be something that comes from the information about the number of beings. Likewise, makes no sense to call the pre-execute hook method on the async task. This isn't something that has anything to do with executing a task on the executor. Let's take a look at some problems I saw with the cancel method that was defined in the async task class. First, make sure you always check to ensure that async task is null, or rather not null, I should say, is not null before calling cancel. If it is null, you should not call it. There were lots of strange implementations of cancel. You shouldn't be checking if interrupt if running is true. That's meant to be called, that's meant to be passed into the cancel method on the async task. Definitely makes no sense to try to cancel the current thread, which was what this code is doing. Why on earth would you want to cancel the current thread? The goal is to cancel the async task that's running in the background. As always, again, make sure you check to see whether the async task is not null before calling cancel. This also makes no sense. Why are you calling shutdown now? You're supposed to be canceling the async task. That's the purpose of this. Yet another problem I saw, sometimes people were calling the onCancel hook method. Those hook methods are not intended to be called back at all by client code. They're meant to be called back by the framework, and they're meant to be called back if the task is canceled. And that's what you need to do here. You have to make sure you cancel the task. There were also a bunch of really strange implementations in do in background. In particular, this code is waiting on the barrier and then calling acquire Palantir and gaze. That makes no sense. That doesn't have to be called. This code is even more strange. It's going to iterate through the max iterations, the number of iterations that were requested, calling entry barrier await each time. That makes absolutely no sense. Again, you don't need to call acquire Palantir and gaze. That's handled for you by the method that's already in do in background. I think it's called something like run simulation. And something very important is missing here. You read the instructions. You're supposed to wait for everybody to be ready to go before you let them start. So you need to use the barrier call there. Actually a couple of people called await in on post execute. That makes no sense. That doesn't belong there. Several people called the notify method on the async task. I have no idea what that was meant to do, but this is where you're supposed to essentially inform the exit barrier that this thread is finished, so the exit barrier can be released by the main thread or the calling thread, the one that sets all the wheels in motion. Definitely calling notify is not going to have any sensible effect whatsoever. In the begin async task gazing method, there were a number of common problems. Make sure you get the count right for cyclic barrier. You need to have a count for the calling thread and all the background threads. Have no idea why there is a barrier action here. Makes no sense whatsoever to create a new thread. That's just putting gobbledygook in for no reason. Also, make sure that you get the right count for the countdown latch. This count is incorrect. Make sure to use Java for each loops instead of, for each methods instead of for each loops. And this code here makes no sense. Submitting a thread factory as a runnable to the thread pool executor. Come on, that makes no sense. That's just nonsensical. You're not paying any attention whatsoever if you're trying to write code like that. Here is, make sure that you catch any exceptions and print out the error. That's the simple thing to do. A lot of bizarre things were in wait for async task to finish gazing. Calling reset, that's the wrong method. We're supposed to let them all start running. Calling reset is going to reset the barrier and cause an exception. Likewise, you're supposed to wait for everything to finish. Calling countdown in the exit barrier will not have that desired effect. Here's some even stranger code. This code attempts to go ahead and create being tasks and run stuff in the background. This completely misses the point of barrier synchronizers and async tasks. Same mistake that's being done down here. Again, completely missing the point of the barrier synchronizers and what their role is and the way that async tasks are supposed to work. Some more problems here. Don't be calling these methods. Instead, be using the entry and exit barrier appropriately. It's really, really, really straightforward. So sit down and think about it a little bit and make sure your code is passing the unit tests. Lots of strange problems in Acquire. This one isn't particularly wrong. It's just inefficient. You can use the set value method on the entry instead of calling replace. That's a kind of a simple one. I've talked about that in previous frequently made mistakes. There's kind of a mistake. This iterator should have the generic parameter filled in. It's not done correctly here. And this is way too complicated. I really don't know what this is supposed to be doing, but it's way too complicated. All you need to do is use the get value and set value methods on the entry set as you iterate through the entry set. There's some other rather bizarre things in here. This code makes no sense because the stamped lock, read lock mode isn't being used in any sensible way. We're trying to convert to the write lock, but we don't do anything sensible. We're just going to keep looping over and over again, so that code is wrong. Take a look at the documentation for stamped lock, and it shows you some examples of what patterns to follow when you do this. And then again, this code makes no sense. Just putting random things in there appears to me. Some more problems in Acquire. This code makes no sense. Don't need to be calling contains value. You should be using the entry set, not using method calls on the Palantiri map. You should be looking at the get key and get value and set value and so on in the entry set. That's much more efficient. This code is just sort of senseless. I don't understand what it's doing. Here's an interesting example where this code is kind of right, but after unlocking the read lock and reacquiring the write lock, something really important is missing here. And so this code actually won't start back over again at the beginning of the iterator. So that's a little hint for you. Various problems in release. This particular code had no locking, so it was just a giant race condition waiting to happen. There's no mutual exclusion provided by stamp lock, which is the whole point of this. This code was bizarre. It called stamp lock try write lock, but didn't store the value anywhere and didn't use it anywhere, and then used a synchronized statement, which made no sense because the whole assignment was about stamp lock, not about monitor object synchronized methods. Make sure you only call the release method if replace or put succeeds. Don't just call it unilaterally. And here is a subtle thing. This code isn't really wrong, but it's a good idea to refactor it so that the unlock write method call is in the finally block. And then after that, if you need to release the semaphore, you do so. So that just has to be refactored. This code makes no sense because we're calling shutdown now twice, which doesn't make any sense. We're shutting down the thread pool executor. We shut down now, and then we're shutting it down again. So it's kind of a belt and suspenders approach, but it's not what you need to do. Instead, what you need to do is you need to cancel all of the async tasks. So that's kind of a hint as to what you need to do there. So those were the various frequently made mistakes that I found. Some people did very well. If so, I probably sent you an email and said, good job, or I had one or two really minor comments in your solution. Other people just appeared to be throwing spaghetti at the wall, clearly they had made no effort whatsoever to think through what they're doing. And some other people didn't actually have any code pushed to the repository, so I couldn't review their submissions. Take a look at the Piazza site. I have the updated due date when everything is going to have to be submitted for the final grading. And as always, if you have any questions, please let me know.